This is the second video of lecture 4. In this video, I go over two schools of IT project management, traditional project management, which is also known as the Waterfall model, and the Agile project management. I don't use an academic paper to provide recommendation to the CIO in this video, since there are some critical concepts in the chapter 6 of the textbook, which require further clarification, and knowing them is quite important. Let me provide a background for why we discuss agile versus traditional project management. In chapter 6, we learned that Jim Barton, the CIO of IVK, had a project status review meeting to check if projects are behind the schedule, over budget, and whether the projects achieved the milestone in terms of the tasks that had to be completed. Each project in that meeting is assigned a color. Green means everything was in order. Red means the project was way behind the schedule or over budget. There were two IT subgroups. One was following the Agile school of thoughts, the loan operation systems, and the other one was following the traditional project management teachings, the customer support systems group. Both groups had many reds and yellows despite what they have reported. And at the end, Barton, the CIO, asked, why is it that we are behind the schedule and over budget on so many of these projects? We want to know the answer to this question by these two school of thoughts and their solutions for this problem. But first, let's get familiar with these two schools of project management. The traditional project management is developed based on the teachings of project management in other disciplines such as building constructions. Here, first, all requirements are specified and documented. The people who does this part are called business analysts, and what they do is they try to create a scope for the project. The next step is to design the software application. The outcome is a software architecture that shows what components exist in an application and how these various components, such as databases, tables, piece of programs, DLLs, are related to one another. People who are in charge of this phase are called software architects, software engineers, or solution architects. Afterward, a software application is developed by programmers using a computer language such as Python or Java. Of course, this development is completely based on the software architecture. Next, the quality of the application is tested to make sure it covers all the requirements specified in the first phase. After this phase, the application is deployed. It will be used by the users in the organizations. The last phase is maintenance, where the application is updated if users bump into any issues or if they find a way that the developers can improve the usability of the system. Note that a complete functioning product is delivered at the end of the verification phase. Therefore, Budget cuts halfway through the project means no functioning program. The agile project management goes through all these phases in iterations. After each iteration, there is a somewhat functioning product. So in the second iteration, you're going to have a product with more functionality. In the third, this will be increased, more features are being added. And this iterating is continued until we have a complete functioning product. So note that uh, as you can see here, a somewhat functioning product is always delivered to the organization. Therefore, agile programs can absorb budget cuts due to economic downturn or a changing strategy way more easier. At the beginning of a project, it is a good practice to specify three items: the scope of the project, which means the requirements; the schedule, which means the deadlines for the tasks and milestones; and the cost, which means the required resources for a project. With the waterfall, the scope is established and fixed, while the budget and time are often considered flexible uh, to make sure all required functionality is delivered. This means that the project isn't considered finished until it meets all the requirements. On the other hand, with the agile project management, the scope is not clear at the beginning. Requirements can change during the project, which means project managers aim at covering as many requirements and new features as possible while sticking to a fixed project and schedule. Note that in each iteration, the new and existing requirements are prioritized to deliver a product with the highest value for the organization. Now that we know how we do things in either of these two school of thoughts, uh, we can answer the question by Jim Barton. Why is it that we are behind the schedule and over budget on so many of these projects? So the answer by both school of thought is that the requirements are unclear. You may have seen a picture that have been circulating the social media for perhaps tens of years, where how a customer explained what it wants, how the project leader understands that, how the analyst design it, the software architect design it, and how the program, create the application at the end, and what the customer really needed. So there are differences between, uh, the understanding of all these people who are stakeholders in a project, stakeholders of a project. And another issue is that the requirements are constantly changing sometimes. Um, this has happened, in many projects, software development projects, and it's a well-known fact. Although both schools of project management blame uh, the issues on the constantly changing of the requirements, they provide different reasons for this requirement changes. The traditional project management attributes that to the lack of discipline, not doing enough planning at the beginning, and failure to establish clear requirements to make sure that the customers fully, you know, provides all the requirements. And also, uh, they attribute this requirement changes to the software development team, to the project managers who allow scope creep, which means, some small requirements are gradually being added to the list of requirements. So this makes the success a moving target, and therefore it is difficult to uh, achieve the goals of the project. On the other hand, the agile project management believes that requirements do not exist at the beginning of the project. Users you know, are not expert enough to be able to explain what they want, or even uh, uh, understand what they want from an application. Even if they know what they want, they cannot communicate, their needs with the project managers. And also, because the business environment uh, can change quite fast, especially these days. Um, Problems cannot be anticipated. Requirements are also uh, being changed as a result of those changes in the business environment. So, in summary, uh, the Agile would say that requirements cannot be identified at the beginning. The traditional approach would believe that the requirements uh, are not, established at first because of the laziness or uh, laziness of the team or their inexperience. So, what is the suggested solution by these two school of thoughts? The traditional project management would say that we need discipline in planning. We need to emphasize on having a kind of fixed and firm agreement before, you know, we can start the project. That means the uh, client of the department, the client of the project, must sign formally that these are the requirements in the contract and we are not going to change that. And if a requirement outside the contract is, uh, you know, is given to the project team, then the client must accept that we need to adjust the budget and the schedule of the project. We also, as project managers, need to have contingency plans. That means we need to uh, extract the incidents that can happen during the project that would not allow us to meet the budget or the deadlines. And then we can have a kind of plan for them. So we create these plans even before start designing the application and developing uh, the software application. And then if something happens, we just know what we need to do. On the other hand, the agile school of thought uh, would say that we shouldn't waste our time on planning. We need planning for sure, but just don't waste your time on planning. Start building the system fast by creating prototypes, small softwares, as a somewhat, an application between that has covered some requirements to be able to, figure out what the requirements are so that, the user can understand his requirements if, he or she sees these prototypes. Or, if creating a prototype is difficult, we can, uh, show the detailed walkthrough of, of a process. We would show them snapshots of, the interfaces that the users would see for these big projects. And they believe that we inevitably have to accept that messes are going to be there, but we need to be aware of these messes, faster, earlier, rather than, knowing about them when they are turned into a big disaster. So the motto of Agile project management is fail faster to succeed sooner, um, and that we need to have active attentions to the details, because these details are the source of those big problems and not being able to meet the budget and the schedule deadlines. So which one we should go for? You are the CIO of a company, and there is a project, and you need to make decision if it should be managed using the traditional project management or the agile project management. So if the requirements are clear at the beginning, and you're sure that the environment of the business are not going to change uh, drastically, changes would be small, and you have a customer who is patient. That means they can wait for 1 year or even 2 years to have the application. And the culture is quite mechanistic. That means these people would not expect change. They and the changes are from top to the down. Uh, the employees follow the procedures quite, greatly, and there is no organic way of dealing with things. For each issue, for each product, for each event, there is a process. Then you can go for the traditional project management. On the other hand, an agile project management is a good choice if, the project is very exploratory, which means that this is a kind of new type of software application that have not been seen anywhere else, or we don't have access to those data, um, or uh, when the project requires uh, high customer responsiveness, showing them prototype would uh, would motivate customers to be more responsive. So here again, agile project management is a great choice. And finally, if the organization is very innovative and the culture of innovation is quite high in the innovation, uh, the culture of accepting changes is quite high in an organization. So people are quite, they would like to see the outcome of the innovation quite fast. So here, agile project management is again the correct choice. But most of the time, the condition is not as clear as what mentioned here. It's a mixture of all these conditions. So that's what makes this decision quite difficult, make it difficult to choose between Agile and Waterfall project management. Pause here for a minute and answer this question. The textbook introduces Gantt chart and critical path as two tools that project managers use to keep that project managers at IVK use to keep projects on schedule. I would like to explain these two approaches, which are mainly used by the traditional approach to the project management. What a traditional project manager does as his or her first task is to find all tasks to be performed and the, their interdependencies. That means which task must be first uh, completed so that the next task can be done. Here you see that A1 should be completed so that we can do A2, and to start A3 we need A2 to be completed. Then the project manager finds the critical path, the path along which any delay means an overall project delay. As you can see here, the green path, which is A1 to A3, takes 27 days according to the project manager's estimation. And the lime green path, B1 to B3, takes 12 days. And the red path, C1 to C3 takes 30 days. So it is obvious that the red path is the critical path, and the tasks in this path requires extra scrutiny. The project manager should be always um, vigilant and figure out how many days they are taking. Note that, along the project, if, you have not enough resources, you may go for, attributing those resources to the red path so that the project is delivered uh, in time. But that means that the other activities in the A path or in the B path can be uh, uh, done later, which means that they can become critical paths in future. So this analysis of critical paths should also be done whenever we see delays in other activities in other paths as well. So after creating this critical path, after we found out the interdependencies between the task and how many days uh, they took, it took to complete a task, then we can develop a Gantt chart where all tasks and their starting date and duration are shown in one view. Each task has a starting date and also an ending date, which is have a, this diagram can have this look at the beginning of the project, but as we try to do the task in the during a project, the diagram can also change due to the delays, due to not having the resources, or any kind of risk that can be materialized. Note that the traditional approach also uses other ways to uh, so that the projects are delivered in time with the quality that is expected from them. Uh, One approach is to measure your project management capability, and good way to do that is to use CMMI, the Capability and Maturity Model Integration. So there is an institute that will come to your organization and will investigate how your processes are during a project management. They will ask about how you do things, and then they will give you a score from 1 to 5. One is that means you're at the uh, beginning of your journey to have a mature project management um, capability, and level 5 means that you're at the best place possible in terms of project management capabilities. So uh, the thing is that most software companies, for example, as an Indian software company, they try to mm, get this score to show to the real world that they can be a good partner for the digitalization of an organization. So, but what does this mean? What does these stages mean here? So, in the first level, in the initial level, you almost don't have a process. Your processes are not predictable. You don't know how long does it take to do a task, and you don't have good way to control the process to make sure that things are done in the time in the time in the schedule that are uh, identified specified for them. In level 2 you have some sort of project process. um, that means the task that should be done for a process for a project, uh, and you have a good estimation of how long would that take. But the thing is that when you are trying to do the project, you figure out, oh, we need these tasks to be added to the process as well, or this task should be done before the other task. So the process for software development is not mature, and you need to add tasks, update tasks, or remove even remove some tasks from the process. In level 3, what is interesting is that you have a kind of a standard process, and for each project, you have a good understanding of what task should be done in what um, sequence and when a product should be delivered, an intermediate product should be delivered. So uh, having this standard process can help you to develop a quite feasible uh, process for a project that you're going to do for a type of organization. So the great thing is that you have so much experience that for each type of your customers, for each type of deliverables, you already know the task that should be done and the sequence. So you have quite a great process for each type of uh, customer and each deliverable. In level 4, what you do is you to you constantly measure you know uh, yourself, so that you can figure out, you can analyze, um, so you have a kind of um, a pool of data. Your goal here is that you to create a pool of data to figure out how long a task takes in reality. So in the next level, when you go for optimization, you know how you can improve each of these tasks. Pause here for a minute and answer this question. Okay, now I would like to explain the possible effect of your choice for project management on IT architecture. And with that, I will go over some concepts in chapter 7 of the textbook. First, let's learn what an IT architecture is. An IT architecture is the overall design of computing systems in an organization or part of an organization. One example is the applications and their relationship can be shown in one view. Uh, for example, here you can see that the clients have a direct relationship with the front-end systems, their order placement or the customer relationship management systems. And the front-end systems exchange data with the middle-end systems, which include order fulfillment and inventory management and shipping systems. And these middle-end systems themselves have they exchange data with the back-end systems such as accounting, human resource system, finance system, and production systems. So in this view, we have a kind of understanding of the overall design of the application system in an organization. Or we can just go into the depths of one application and see the design of different components inside that application. For example, here you see that a user gets connected to one of these systems. Assume that the order placement system through the internet. There is a front-end component that is designed by front-end developers that gets username, password, and allows you to sign in. And after that, it can show you the product that you can buy, and then it gets the order from you. Behind this shell, behind this user interface is the backend component, which is the business processes behind these interfaces. For example, how should we calculate the total of the cost? What should be what kind of product should be shown to the user? So the front end is just about the beauty and the organization of the information. The back end makes decision what information to be shown, what information to be processed, and things like that. And of course, the backend component itself has, requires data which, exists in the databases. So there is a connection here. This is called the three-tier architecture. We can have n-tier architecture, and this is just for one application. Again, it's just inside what happens inside one of those applications that you saw in the first view. So this is an IT architecture. An IT architecture can be quite, complex for some companies. As you can see in this picture, we have many systems and they are all connected to one another in one way or another. And are um, these are so complex that even viewing what happens in an organization is in one in one view is not possible. So we call these systems spaghetti systems, which are the result of collages for fast system development. A collage is a quick and dirty solution that is clumsy, irrelevant, inefficient, difficult to extend, and hard to maintain. But this resolves the issue for that moment. So again, next month there is a need by there is a need by the top executive. So you just quickly create a new application, a new system, and add it to this, already complex system, and you increase the complexity even more. So the thing is that agile project management is more prone to developing, spaghetti systems. Not that, the traditional approach cannot make it, but the focus on traditional approach, if they try to establish requirements quite uh, in an efficient way and consider uh, other applications that exist in the organization, they have a higher chance of, uh, doing it in a way that complexity is not increased. However, so still, traditional approach can create the same spaghetti systems, but the agile approach has a higher chance of doing that because they just jump into developing an application. So what are the risks of spaghetti systems? Why do we don't like a spaghetti system? So first, IT wise, uh, the system, the interdependency of the system are quite complex. And when you add a new node or change one node, it has the business risk of, you know, losing, that component because you try to improve, for example, Osiris, the course registration system, but that will have an effect on the learning management system of Canvas. So, and you don't know because the complexity of these interdependencies are so high that one small changes in Osiris will cause the canvas to go down. So you need to uh, uh, try to decrease these complexities, uh, complex interdependencies, so that the systems have a higher level of availability. Also, in this system, it's very difficult to integrate systems so that, for example, financial systems and the loan operation systems at IBK can exchange data. As a result, at the business side, you don't have enough control, for example, financial control on what's going on. Decision making is usually based on incomplete data because you cannot gather data from different places easily. And you also get more vulnerable to internal security threats because people who have access to one system can uh, get in a way have access to other systems. The systems are so complex that the IT security officers cannot be as effective as an organization needs. It's also very difficult to implement a real-time system that can, uh, deliver a, a service in less than 1 second, for example. Assume that Amazon wants to show products similar to the product that you want to know, so you're going to buy, or Bol.com wants to show you what other products are bought by people who bought the same product that you're buying. So here you only have less than 300 milliseconds to show those products to these people. But because the system is so complex, it can be quite difficult to get information about the customers from different databases and make a good decision. So the thing is that this makes supporting um, uh, real-time responses to the market difficult. You cannot have flexible pricing. You cannot have marketing metrics that can uh, help you to make a comprehensive, good decision and then uh, implement it fast. So what is the solution for spaghetti systems? So it is called enterprise architecture, or the abbreviation is EA. Rather than just have an IT architecture for one system or one or two divisions or part of the system, part of the enterprise, you try to focus on the entire organization and create an IT architecture for the entire company. And then you develop maps, blueprints to show the current architecture of all the systems. After that, you develop blueprints that represent the desired architecture, what you want the systems to look like and how they are going to be related to one another. And after that, you develop a roadmap for the transition from the current architecture to the desired architecture. So EA is more aligned with the traditional approach again, because you need to spend a huge amount of time to create the current architecture and then develop the desired architecture and the roadmap. This means that the requirement phase is quite, time consuming, which is against, Agile's approach where it asks you to just jump into the developing as fast as possible. There are, attempts to uh, combine EA with the Agile. It's called Agile EA, but I'm not sure if they are successful enough. Pause here for a minute and try to answer this question about spaghetti systems.